So hello everyone, this is today's question. And first of all, we will read the questions carefully. After that, we will solve the questions in two ways. And one is the brute force approach, and one is the optimized approach, that is segmenting. Okay. So first, let's start the reading. Let's start the what the question says. The question is saying that range LCM queries. So what does it mean? It means you are given an array and a list of queries. Where the list of queries contains two types of operations. One type of operation is updation operation, and one type of operation is range query. So what is updation operation? For the updation operations, you have index and value, and you have to update the array of the specific index that is mentioned in the operation with the new value. Okay. And what is range query? The range query is you are given and left and right value, that is basically the indices, and you have to calculate the range LCM, that is the from array A left to array right, the subarrays LCM, the LCM of the subarray. So you have to find these two operations. And here, like by default, in the as all the questions, it is zero-based indexing. So let first take the first example, that there are two there as for the first test cases. Okay, so 2, 3, 4, 6, 8, 16. See 2, 1, 2. So as I have mentioned, and in the questions it is mentioned clearly that two operations range operations and one operation is updation operations. So here it is two operations. So 0 to 2, it means from zeroth indexing to second index, the total LCM will be what? 2, 3, and 4. It will be 12. Okay. So if you can calculate, you can calculate easily. I hope I don't discuss here how to calculate LCM. Okay. So let's next move forward to the next part. And the 138, here one operation is updation operator. And at the third indexing, like third index, like what is the third index? Third index is 6. You are updating with the new value, that is 8. Look, the updated array is 2, 3, 4, 8, 8, 16, rather than 2, 3, 4, 6, 8, 16. Okay, I hope this is clear. And as you can see, the second test case also, they are also like performing the operations as it is mentioned in the questions. Okay, so I hope this questions statement is quite straightforward. But to solve the questions, we have to like first we can solve it like a brute force approach. But I don't want to go into the brute force approach because I just discuss it here verbally. So I hope you can catch that. So what we can do? We can do that. We have to make an LCM, like we have to make two pointer, the for each query. We have to check the if the what is the type of the query. If the type of the query is first type, also we have to just update that value. So we can do that in big of one time, because updation of any element or on a specific index of an array takes big of one time, irrespective of the language. Okay, and but it comes struggle when it is comes to calculate the LCM part, because for LCM part, if you making the brute force approach from 0 to L to R, if the brute in the worst case, the L part is 0 and the R part is like N minus 1, then to calculate LCM from L to R, each element in the one by one, then it will take almost big of N, big of N log n time, okay? Big of N log n time. So for each element, it takes for each queries, it takes almost big of not big of n log n, near about big of n. Okay, and so almost it takes what? Almost it takes big of n time for each query of type 2. Assume there are n queries, because here it is mentioned. Here it is mentioned the query size 10 to the power 5. Assume there is 10 to the 5 queries, and each query have the each queries are of two types, type 2. Okay, because we don't know how many how many queries have type 1 or type 2. So I have to write the code irrespective of the test cases because I don't know the test cases, okay? Because there are some hidden test cases. So you have to assume that worst case, okay? So the for worst case, there are m like all the types are type 2. Like we have to find the range query. So for that case, for each and every query, we have to perform the LCM. And to perform the LCM of n elements, it will take almost big of n time or more than that, okay? Because to perform LCM, it will take more time. So for m elements, for m queries, and for each query, it is take almost big of n time. So the total time complexity will be what? Big of m into n or n plus some extra time. So what is the constant here? The constant is 10 to the power 4 array size and 10 to the power 5 query size. So 10 to the power, it is exceeding 10 to the power 9 because some extra time would also be needed for calculating LCM. That's why it will give TLE. We all know it will give simply TLE. I don't want to code it because I have to make you understand the actual part, that is segmenting, because it's a advanced data structure, and to understand this you need some time, and I don't think that if I go to the brute force approach and to code it, it takes most time, it takes much time. So I just tell you that what will be the consequences if I run that. It will give the TLE. So I move forward the optimized approach, that is segmenting. So for that I will take the reference of Google Slide, so that I can make you understand very clearly. Okay. So let me open that. Okay. So I am taking the example of the first test case because I hope this will be clear. Okay. Paste. Okay. Yeah, now it's clear. So, so basically, what is segmenting, and why should I use it? Because segment is an advanced data structure, which is used to update to update to get our answer, or for query, or for like to update and get our answer, and to update and get our answer. Sorry, my mistake. In big of login time. So that is the advantage of using segmenting. Okay. But what you will say, so what is the problem with the brute force approach? Yes, in brute force approach, you can get that element, or you can get update that element in big of one time. That is for sure, because you can just update it in the index. But if it like big of, like for each and every query, if for each and every query you have to perform the LCM of all the elements in the range. So for that it will take almost big of n time. So as I have before mentioned, that we don't know how many types of big of to a second types and how many types of first types. So if it is mentioned, just we have to just update it, then we'll obviously go to like range LCM, like for the first group perceptors, because that will be most optimized. But here updation as well as uh, getting the answer, getting the query LCM is also needed. So we have to set the code in such a way that it is optimized in both ways, like in both updation and as well as query. That's why we are using segmenting here. Okay, I hope this is clear. So now I will say what is segmenting and how it is built. So before going to, like I have said that what is segmenting. So the segment tree, you will say that segment tree is a tree. Okay, segment is nothing but a tree. It is a tree data structure. But the segment is used because we solve the questions using segment tree by making that questions by divide the questions in small chunks or small segments. And after getting the answer from the small chunks of small segments, we will merge them and get our actual answer. That is why this is called segmenting. Nothing more than that. This is the segmenting. Okay. So then we'll go to how can we build the segmenting, because we know that what is binarity, what is emerity, what is BT, B plus T, something like that. Segment is simple F3. Simple F3. So how can we build that? Okay, let me build it. Like, I hope you will know that massive, that we can make an heap with an array. Okay, say like in such a way we can make the segment T from this also. So how can it possible? It can be possible with the array, because as we make our segment T, make a heap, like if you have started the heap data structure, then we also make our heap with the array only. Okay, so here also we will make the segment T with the array. So for that, to segment to make the tree, we will take array size a array, like I will later first let me write the code, like pseudo code. Then I will understand why I am taking the array. Okay, new int, and here I am taking 2 into n. Like you can do 3 into n also, no problem. Okay, so so after that, what I will do, I will like build it, because to perform the operations in the tree, we have to build it first. So how to build it? So I just want to build it. Okay. Uh, int LCM int build. Okay. So for that, for building it, it needs some parameters. That is node. That is the current node. That is the root node. That is and what for making the segment we need node. Okay. And int node int value. And we are given the array, so I don't need value here. Okay, and left int right. Here left right means we want to make our tree. We want to make our tree with this tree data structure, with this tree array, and our as we are make the segment tree for the purpose to solve the question. So here left and right pointer is the initial index of that array that is given in our questions, and the final index of that array, that is the total length of the site array, that is 0 1 2 3 4 5 6. So that will be here, it is 0, and here it will right here it will site. Okay, so there is a conditions, like when we want to, like it is a recursive approach to make the tree. So we have to stop them when left equal to right. Okay, left greater than equal to right. I can say that. No problem. So then we have to just t of left or t of node equal to what? T of node equal to uh, array of left. Sorry, my mistake. Array of left. Here left equal to right. Because why I am writing this is because here left and right basically making the array the chunk, because as I have mentioned it is chunk the or the segment, it makes a segment to the array. Okay, so it is segments the array. So if left equal to right, so we have just one element, then we have to stop there, and tree of node will be array of left, and here the trees of nodes storing that the node for the left to right pointer, the LCM stored in the node. So what the node is storing? The node is storing because here I have to solve the LCM. If you have to solve the sum, if you have to solve the product, then also you store that product also, product logic here. But here I am storing the LCM. That's why I am storing it tree of node equal to array of node. Okay, because if left equal to right, then we all know LCM of x because two same elements LCM is also is always like that element. Okay, because this holds the idempotent flow. So after that, what we'll do? We will do calculate this left child. Okay, so int child, left child, left child return left child what the left child return? Left child will return the LCM of the left two subtree. Okay, and what will be that? What is the left child node? 2 into node plus 1, because we are constructing our array, or we are defining our array in such a way that if any root exists on ith index, then its left child will exist at 2 into I plus 1, and its right child will exist at 2 into I plus 2. Okay, so then what we'll do? Left, and here I have to calculate the mid, because that's why logic is log a, because we always divide the whole array in a in almost equal partition, like for an example, if the array size is initially is 8, it will then partition will be 4 and 4, then it will be like 2 and 2, then it will be 1 and 1. Why so? Because it will help us updation or query method. Okay, so make that big of login time. Okay, that's why we are taking that almost equal partitions, and equal partition logic will be simple: left right minus left by 2. Okay, that is, I hope this is clear. By 2. Okay, so left mid, it is the left child node, say, children. And what will the right child? Right child will be very much easy. Right child will be build 2 into node plus 2 mid plus 1, because we have calculated till mid, so we need mid plus 1 to write, right. Okay, and after the whole method is completed, then we have to store that actually our in our answer. So what will be that? T of LCM equal to, that is LCM, that is left child, right child, simple. Then we have to just return what? T of node. That is the main logic here. Okay, I hope this is clear. So this is a build logic. So as I have written that code, I will just code it in the ID. Okay, so I can. This is the GCD logic. I hope this is clear. This is the LCM logic. I don't go into the LCM logic because it is very basic. This is the GCD, because we all know A into B, if the LCM of any two elements is A and B, so the GCD of the two elements will be like A into B by the LCM of A and B. So basically LCM of A and B into GCD of A and B equal to A into B. Okay? Yes. So I keep this LCM and GCD methods, and I will write the remaining logic. Okay, as I have mentioned here. So let me write a build logic here. Okay, and as I mentioned, we have to make tree. So let me make it long tree. I'll give the size, any size you can give. Okay, but it should exceed like two into n plus one. It should exceed that. 4 into n, I will give no problem. Any size you can give. Okay. So after that, we have to make the build logic. And the build runtime will be int. Sorry, you have to this all along. So I will deal it now. Okay, I don't want to take the risk. So int node, int left, and int right. Okay. So what is this? What is the base case? If left equal to right, then return t no t left t left. Okay. What will be that? T left or T right? No, T node. Sorry, my mistake. My mistake. T node equal to what will be this? Array of left. And here are you also dictionary is global, so I don't want to pass it as argument multiple times. Okay. So array of left. Okay. And what is the remaining case? If this is not the condition, then you have to find the mid. In mid, what is the mid? Mid will be right. Sorry, left, left plus right minus left by 2. Okay. And what is the left child? Left child, what will be there? 2 into node plus 1. Clear? And what is the right child? Right child will be 2 into node plus 2. That is also clear, as I mentioned there. 2. Okay. So, what is the left answer? Because LCM of the left subtree, what will be that? LCM left, LCM left. That will be stored in here. It will long. It will be long. Sorry, my mistake. LCM long build left child left mid long LCM. Sorry, this will be left because naming is very much important to understand the code. Build right child mid plus one. Okay, and right. Okay. So here I will calculate the left LCM and LCM right. Then after that we have to return that is tree of node equal to what will that LCM of LCM left LCM right. I hope this is clear. Okay. So you have made the build logic. Then we have to make an updation logic. So how can update that? So next for that we will take another slide. Let me code it because this is almost similar. Almost similar. Okay. Yes. So understand. For updation, there will be left, right, and there will be another two variables, that is index and the updated value. What we have to update. Okay. And I will change it to update. Update. Okay. Yes. This clear. Yes. So here you can yes. And you can like make them void because I don't know it in here. Because I will explain it why I don't read it in here. So like if left, so here will do here. What is the conditions here? If left equal to right, then we have to return that. Okay, have to return. But if return, in another condition, what will be that? If if yes. So here also take me look another thing. Yes, index is always like in the array size. So I don't want to need that. Okay, it is not needed. Okay, so what is this? That is idx idx equal to idx equal to what? Idx equal to sorry 1 minute. Yes. if left equal to right and idx equal to left, then only we can update t of left, t of left, t of node, sorry, my mistake, t of node as value. Okay, because in that index the value is now changed, and for the remaining field, then we have to check either this is not the case, either this is not the case. We are not in that, we are not in that position, like we are not in that mode. So we have to update that. So for updating, what we have to do, int, we have to check what? We have to check if idx greater than equal to mid. If idx greater than less than equal to mid, then we have to move backward. Then we have to move backward. Update, sorry, this update. We have to move the left. Sorry, my mistake. We have to move left. So node 2 into node plus 1, because I have told that 2 into node plus 1 is left side, a left and mid, simple. But if this is not the case, then for sure this ideas will exist on the right side. So then we have to update that. Update 2 into node plus 2 mid plus 1 and right. And also we have to write that index here only. So because this is checking at every level of calling. Okay, so index and value. Okay, so this is the update. Then after updating, we have to calculate, we have to calculate what? We have to calculate, tell how to calculate what? Yes, we can just LCM of 3 of 2 into node plus 1 or 3 of 2 into node plus 2. Okay, so that is the fact. Let me take a call on this. Yeah. So sorry for the interruption. I had take the call. Okay. So that is the update query. So then we have to don't return this. So then we have to just, it's like if, as it is white, so you don't have to return. Like don't have to write here. Okay. So this is the code for the update. And let me copy it. I will just copy it. I don't write the extra logic. I will just copy it. Okay. Let me format it for a little bit that it looks beautiful. Update. Yes, it's but there is some mistake because there is for auto writing. The else is like it is starting from the capital letter. It will give the compilation error. Let me fix it. Yes. Now it's clear. Now it's and void is also like capital. Now it's fine. After that, we have to make our last functions. So what is that? We have to find our answer because we have to create our field. We have to create our weapons. So we have to fight it for. We have to use it in the fight battle. Okay, just for fun. Okay. So let's move forward to the last and important portion. Okay. So next we have to given that update query is already done. Update is already done. So we have to just now query for the first type query. Let me copy it because it is used, the same structure is used, will be used here. Okay. Yes. So I will simply like update this, I will give this, what I'll do, int void, you can give like, alright. Yes, you will give obviously the long because it will return the long value. Okay. That's it. Long query, yes, you can give this query, yes, yes. So here the left and right will be there, and the remaining part, that is L and R, int L, int R, it will be also there. Okay. So then there will be, when we have to stop that. When we have to stop, There are certain base cases. I'll explain here one by one. First let me write the code. Then I will explain why is this happening. Why is this important that you are writing, that I am writing in such a basis? Okay. But the first basis will be if the like if the range that is N and R is completely outside of the left and right. It's completely outside the right, left and right. Then we can say, then we have to return one. So what does it mean? If left is left, less than L is left, sorry, I'm strict. If right less than L, all left greater than R. Am I right? Am I right? Am I right? Right greater than L, right less than L. No, sorry. Because left and right previously defined, the LR is varying. Okay. So if L, like our query left is, sorry, our query R right is less than left, or that is if the R is itself less than left, so L is obviously will be less than left, so it is completely outside of the range. Okay, that is I am saying. Or L less than greater than right. So what does it mean? If L itself is greater than right, and we all know that L R is greater than L, so R will also be greater than right. So L and R, the whole range will be the outside of the left and right. That is why we will return one. Okay, and that is another condition. If this L and R is completely like the left and right, this left and right is completely inside between L and R. What does it mean? That perhaps there is L is 4, and R is 7. Okay, and assume left is 3, left is 3, and right is 5. Then we have to take this entire. We have to take this entire. Why so? I will explain in the as in the text test, in the examples. Okay, let me write it. If L if L greater than if L greater than equal to, sorry, if left, yeah, If L less than equal to start, L is less than equal to start, and start wire to start left, and the R, like the right portion, like the right is exceeding the right. Like I am saying that if such condition left, right, R, then we have to take this whole portions. We have to take this whole portion. That I am saying. The R greater than equal to right. Return what? Return T of node. Okay. This is a two base case. But if this not happens, so there are what conditions is there? That the current segment, that is left and right, is partially covering the left and L and R. The current segment is partially covering L and R. So then for that, we have to check our left and we have to check our right, and merging them, then we have to get our answer. Okay, that's one. So long left. Let me write mid here. I don't want to write same thing multiple times. Yes. Okay. So fine. So left right order. So 20 not plus all left mid, and here also it will be Li, Lr, Lr. Here also it will be what? Lr. Okay. And sorry, this will be long because the long. This will be long. Sorry. So after that, we have to just make the tree of node is what? LCM of T of node, because we don't know T of node. So we have to just make, have to just return the answer. Return LCM, LCM of left child and right child. That is the course, that is the answer. Okay. I hope this is clear. So let me copy it here and paste it here. Because the indentation is very much like important to understand the code. Okay, sure. So int made. So I'll copy it here. Sorry. Now it's clear. Now it's fine. So this is the build logic. This is the query logic. What I am using here. And after that, we will just return it. Then we have to do simple operations, because all tasks which is needed to solve the question, solve the segment, we have built it here. So let's don't define it here. Declare it here. I will declare it here. So t equal to new long 4 into 8. Okay. And this dot array, you can say this dot array. This dot array equal to array. Okay. Yes. Now we have to check for each and every query. And first to take it, we have to make the long array of long and the new array list. Yes, that is yes. We have to show that for the updation logic, we have to write with that. So not updation, for updation logic, we don't have to return anything. Okay. So for int queries, we have to check that what is the type of the operation. Is this first type operation or this is second type operation? So int type u0. Okay. If the type is one, if the type is one, so we have to perform which operation? Perform update operations. So let's call the update operation. Let's call the update operation. Update. What is the parameters? Node, that is it is 0, because always we will initialize it with 0. Left is 0, right is n minus 1. Here I have not defined the n, so you will give the TLE. Very fine. Yes. N minus 1, left, right. So then, sorry, I have forgot to build it first. Okay, build it first. Build 0, 0. It's like you start cooking like without like forget it. So 0, 0 and minus 1 uh, idx, and what the idx will be what? Q of 1, and the value will be what? Q of 2 because it is given in such a way. All is the type will be what? The answer, long answer will be uh, long answer will be what? The query. The query. The query. What are the parameters here? The parameters are known, which will starting it from the 0, starting from the 0. Left and right. Left will be 0, right will be n minus 1. It will be n minus 1. That is, and L will be Q of 1 and R will be Q of 2. I hope this is clear. So after that you have to like add it in the store. Let me change it. Answer store dot add answer, and after done all of these things we have to return this return answer. Let me compile it. I hope some errors will come, but I will fix it. Why it is taking so much time? Let me refresh it. What is this? Error of length. I haven't forgot to give the semicolon. Let's give it. I know that some error always comes. And another things. What is this? Re-upload. In which line? 22 line? Okay. Okay. What is this? Let child build. Oh my. Oh, shit. As I have copied that, so I have also copied here. Build also. Well, well, that is a mistake. I hope there is no such mistake. No. Let's check the answer. Right? Oh, I will just store because this is the answer is just a local variable. Why is it taking so much time? 40 seconds out of bounds, level 24. In which line? This line. Um, 4 Hmm. So, there is some missing or untimed error. Yes, you want to contact value. What is the mistake? Let's change to that non-y plus 1. Let me go to the AI. Here I have, no, I have unable to find the right error. I hope there is some small mistake is there. Let me check. Not this. Okay. Okay. So I have to return it because this is the base case. I have to return it. Yeah. So some mistakes were there because I forgot to return it. So sorry for that. Let's submit it. Yeah, it's submitted successfully. So I have to use some AI because there are some mistakes like I forgot to return this simple line statement because if I don't return it, then it will execute against. Then for that, it will check that two into index plus one. So if it is like that, take the error because error is also important. Like if we check that at the last index here, like if this is 0, 1, 2, 3, 4, 5, okay, so if this is 5 and again we have to we just add the leaf node, but we are again checking that 2 into node plus 1, that is 2 into 5 plus 1, that is 11. So that's why it is exceeding the what can I say, exceeding the index range. So that's why this is giving the error. Now it's fine. I hope this logic is correct, and I have give you the intuition, and some mistakes were there, like small mistakes. That's why I will give you the wrong answer, like the compilation error. So now it's fine. So I have this clear, and the time complexity will be the code of the big of login for each and every individual case. because as I mentioned that each and every time I will just partition this whole array in the two equal subarray so that we can perform the update and the query operations in login time. Because here you can see that we will checking that just kind of the binary search key. If index less than equal to mid, we'll go to this, or else we'll go to this. So that's why this is very much effective, and this is takes almost big of login time. That's it. I hope this is clear. And so till then, take care. Bye bye. And if any feedback arise, then give me the feedback. I will be happy to read that feedback and improve myself. I know that there are some mistakes from my end, but I will rectify it and then from the next video. And please comment me if any doubt arises and if any questions regarding the any kind of algorithms or CP questions. I am also shared my CP profile and lead code. I am also the profiler CP different CP profiler DSA coding platforms such as lead code and GFG coding ninjas. So if any questions arises, feel free to comment it. I will be happy to reply that because coding is fun. So and I want to make the fun and get the fun from you also by solving different coding questions because that is our achievements. Okay, so take care. Bye bye.